Hello everyone, welcome to my channel. So in this video, I will continue our topics on the confidence intervals or say the statistic intervals to guess the conclusion of our population. So for this video, I will talk about how to get a confidence interval for our population proportion. So here, what we do is we only work for this large sample size. So this we need is to be a large sample size, because here what we want to do is we will try to use a normal distribution to approximate our binomial distribution. So before we talk about the confidence interval, let us review briefly about the binomial distribution random variable. So here, if you haven't learn what is a binomial distribution, I strongly recommend you to look at our videos in the channel in probabilities. I talk about several sections about the binomial distributions. So for binomial distribution, so the main idea of this is combined of several Bernoulli trios. So assume here we have small n numbers of the Bernoulli trios, and for each of the Bernoulli trios, they are independent of each other. And for Bernoulli trios, we know they always have two results. One is success, one is fail. So here, the other important parameters for our binomial distribution is this letter p. So this is our probability of in one Bernoulli trios, what is the probability we will get a success result. Okay, so here to get a binomial distribution, we need to have n numbers of Bernoulli trios. They are independent with each other, and they all share with the same probabilities to get success. So that means they will have same value of p. So in this lecture, when we try to guess these parameters, what we want to do is we want to guess the intervals for this true value of our population proportion. This value p is inside an interval. Okay, so this will also need one more thing about what we already taught about the binomial distribution. So when we talk about the normal distribution, we said we can use a normal distribution to approximate our binomial distribution. So if you haven't looked at that video, you should also look at that one. So to use a normal distribution to approximate our binomial distribution, bin parentheses n comma p parentheses. So what we need the n is also large enough. So that means we need to have a large sample, or say the large a lot of the Bernoulli trios. So here, when we talk about use a normal distribution to approximate a binomial distribution, of course, they will have different requirements for this n large enough. So whenever you want a more accurate approximation, it means you need a larger value of n. But in these videos and in our channels, what we mean for n is large enough, this is when we satisfy these two requirements. So that n times p is greater than larger than 5, and n times 1 minus p is also larger than 5. Okay, so based on these two requirements, we can say our distribution, this binomial distribution random variable capital X, is nearly a normal distribution with mean as np and variance as n times p times 1 minus p. So here, if you are familiar about the knowledge of our binomial random variable, you know this np actually is our formula for get the mean of a binomial distribution, and also this np 1 minus p, this is our variance formula to get the variance for a binomial random variable. Okay, so based on this approximation, then we can use the standardize of the normal distribution to define capital Z. So this capital Z is a rewrite of our x minus its mean. So here is NP and divided by the standard deviation. So this means it's a square root of our NP square root of our variance. So in this question, this is n times p times 1 minus p. So now by this standardized of our normal random variable, our capital Z is follows this standard normal random variable. Okay, so now when we already done this approximation, also one more thing I want to let us review before we talk about the confidence interval is what should we do to approximate the value of p here. So because when we do this approximation, when we talk about binomial random variable can be approximated by a normal random variable, we always need two values. One is our parameter n, the Bernoulli trios we have, and the other is about this value of p. So here to do this, what we need, this is similar to the last video. So how we get a confidence interval of a population mean if we don't know the population variance. What we need to do is we use the estimator of this variance to substitute the sigma in our formula. So here what we do is we will also use point approximator of our population parameters to substitute this p in our formula. So here we also talk about this already in our video about point estimator. So a very simple method to approximate is we use this estimator as x divided by n. So here x is the number of success we get in this n Bernoulli trios. So this is estimators of this proportion p. We also mentioned this in our first videos, and also we said for different point estimator different population parameters, we have actually several different point estimators that are not unique. So here, why we choose this x over n here? Because they have a very good properties. So this is, we have this estimator actually is unbiased estimators. So that's why we choose these estimators inside our confidence interval. Okay, so now what we have is we already get this equation, and now we want to talk about how to compute the confidence intervals. So the idea of a confidence intervals is similar with our previous question. So what we want is for a probability, we want to get a left end point and right end point of our make our population parameters is inside these intervals, and the probability of this is happened is 1. The probability is 1 minus alpha. Okay, so here for ours, what we want to do is, of course, the only CDF or PDF we can use here is about standard normal random variable, and to get this equation, what we can write, we need to relate this to our capital Z. So here, what is our capital Z? Our capital Z is in previous video, previous size. We already said this is defined as this equation. And now what we can do is we want to have something about P, not NP here. So what we can do is we can divide it, the N on the bottom and top. So then for the top, what we have for the second term, the N will cancel each other. And then for this bottom, what we will have? For the bottom, we can move this N inside into our square root. So what we have is this is the new numerator inside our square root divided by n square. So what we will have here, this is have the n and the one of the square root on the bottom will cancel each other. So now inside this equation, what we will have this equation is become x over n minus p on the numerator, and the denominator is p1 minus p divided by n inside this square root. So this equation is still our capital Z, right? And this is still follows a standard normal random variable. So now to get our equation of a probability P is between L and R, what we can do is we can rewrite this as we know this is our estimator of our P minus the true value of P is divided by this square root. It follows a standard normal random variable. Okay, so now if you compare this with what we have in the confidence interval for a population mean, you will find this looks very similar. So now if you compare these two, you can see actually the structure of these two equations look similar. Then all the estimators minus population parameters divided by the standard estimation. Standard deviation is follows a standard normal random variable. So now I will skip a little about how to rewrite this to get our left endpoint and right endpoint. So you can look at my previous videos about the confidence interval or say the statistic intervals of a population mean when variance is known to get this step. So now let me write down the final conclusion here for get the confidence intervals for a population proportion. Okay, so this is our formula for this confidence interval, and similar with our previous video, we know this term which is minus for our left endpoint and plus this term on the right endpoint. So this is also our margin of errors here. So this will give us a guess of how wide of this confidence interval. Okay, so this is the end of this videos, and in next videos we will start a new topics in our statistics. This is about how to do the hypothesis test for another important part of our statistics inference. So please subscribe this channel and see you in next video.